So I have a town with a population of 5,000, growing 3% a year, and how long to double. This is going to be a word problem, and it's exponential. So I have my starting value of 5,000, just like we wrote these a few days ago. If it's growing 3%, that's a rate of 0.03, and growing means it's bigger than 1, so 1 plus 0.03. And then I'm going to do to the x is how long it takes. And usually I have a number to plug in, but notice this time it asks for how long, so it's solving for x. That's how these are different than the ones we did a few lessons ago. And then the last thing you're going to have to do is you're going to have a value here. Now, it's a little annoying. It didn't give you a number to plug in, but it did say double. So just think, what is double of 5,000? Well, double of 5,000 is 10,000 because 5,000 times 2 is 10,000. So I have an equation to solve. Now, I could solve this algebraically by dividing 5,000 and rewriting as a log, and you're free to do that. But since we want an approximate answer anyway, Desmos, in my opinion, is the best way to go. So what I'm going to do to get it ready for Desmos is I'm just going to subtract the 10,000 from both sides, and then that means I'm going to be looking for the zero of this equation. So here we go. I'm going to have 5,000 times, and I'm going to simplify that to 1.03, but you're free to type it in the way it was originally. And then to the x power minus 10,000, and I'm looking for an x-intercept. Now, I notice I do not see the graph at all, so I'm going to have to zoom out. And I might have to zoom out several times because you can see how big these numbers are. But in this case, I get a value of this. And remember, if I needed more than one decimal place, in this case, if I needed to the nearest tenth, I would want to see a little bit more than that 5 because that 5 might already be rounded. So what you're going to do is you're going to zoom in a little bit and then try the 0 again. And keep zooming in until it gives you a few more decimal places. So it's kind of the obnoxious part of Desmos is making it give you more decimal places. Wow. Usually you don't have to go at it this long. It must be exactly 23.45, or at least really close to it. So I guess my best answer is 23.5. Now on this next one, what I would have to do is, that one's going to work a lot like the last one, except for this time they actually gave you the number to plug in. So you would have the 175 on this side, and I'll leave it to you to set up that equation. Well, we'll set up the equation together, and I'll leave it to you to solve it using Desmos. This 175 is your final price. Your starting price is 100. It's increasing 8% a year, so 1 plus 0.08, and then to the t. So that's how that one would work. The next one is a compounded interest formula. So we need to remember what the formula for that was. It was A equals P times 1 plus R over N to the NT. And it tells me my starting amount, my principal. My rate is this, so as a decimal, move that decimal 2 places, 0.085. And then compounded quarterly is 4 times a year, 4 quarters in a dollar, 4 quarters in a football game, 4 quarters in a year. And then how long will it take it to double? Well, double means instead of being 5,000, it's going to be 20,000. So my equation will be 20,000 equals 10,000 times 1 plus 0.085 over 4 to the 4t, or in this case, I'll put a 4x. And then if you subtract the 20,000 from both sides, put it in Desmos, you should be able to get an approximate solution.